Hello everyone. Today I want to have a discussion about free electron lasers. They are known as FEL. I want to speak about their working principle and also their applications, and also I want to have some discussions about their advantages. But what is a free electron laser? A free electron laser is a tunable, high power and coherent light source that operates across a wide range of wavelength spectra from microwaves to X-rays. That's why such kind of lasers have become interesting. Unlike to the conventional lasers, free electron lasers don't rely on bound atomic transitions, but instead they operate based on the relativistic free electrons that pass through a periodic magnetic field. As you can see this in this picture, a particle beam enters to the undulators. Then in the undulators we can have generation of different light sources. But about their working principle, the main part of these systems is related to undulators or wigglers. They are a series of alternating magnetic poles that cause the electron to wiggle, and they are able to emit synchrotron radiation. Another important issue related to their structure is related to this fact that they can have coherent emission. As electrons interact with the emitted radiation, the micro bunch happens for the electrons. Then this issue will lead to a constructive interference, and finally we have the amplification of light. These lasers are tunable, and this working principle comes from this fact that we can adjust the electron beam energy or undulator spacing. Then output wavelength is tunable, which is very much interesting, and this is known as interesting feature of such kind of lasers. But let's speak about their advantages and benefits. The first benefit is related to their broad spectral range. Their wavelength range starts from terahertz generation to X-ray to hard X-rays. They operate. They are extremely high brightness and coherence. They have a short pulse duration down to femtoseconds, which is very much ideal for ultra-fast phenomena. And another important benefit which is related to that such kind of lasers is their property or their tunability property. And their tunable output happens via electron beam parameters. We can change the electron beam parameters, and we can have different frequencies and wavelengths. What about applications I have outlined? I am going to outline some of its main applications. First of all, it has many different applications in the field of material science. For example, in probing atomic structures and phase transition. In the field of biology and medicine, such kind of lasers are used and are proposed to use for imaging proteins, viruses, and live cells at nanometer resolution. Nowadays, some big projects are going on, such as LCLS or European XFEL. They are working on the application of such kind of applications of free electron lasers. In the field of chemistry, they have some good applications, some interesting applications. We can use these free electron lasers to study the femtosecond scale chemical reactions, those chemical reactions which happen in the femtosecond scales. And also, in the field of plasma physics and high energy density science, these lasers can be used to probe the warm dense matters. which is very much applicable in astrophysical plasmas. But I want to have a conclusion here. Free electron lasers are able to represent the next generation of light sources. Then they are able to offer the unique capabilities that, in fact, the traditional lasers are not able to provide for us. With expanding the global facilities such as LCLS project or SACLA project or European XFEL project and many other projects similar to these big projects, free electrons are opening the new frontiers in the field of science, medicine, and technology. And in fact, we can have presence of free electron lasers in the field, in technology, in industrial applications. And since they are very much strong compared to the existing high power lasers, they are promising for many industrial and technological applications in the future. Thank you.